Hello, everyone. Good morning, good afternoon, and good evening from wherever you are around the world. And welcome to the Educational Talk Forum on Creep Behavior. I am the moderator for today. My name is Ahmad Khairi bin Tausin, and I am a second year student in Bachelor Mechanical Engineering in University Putra, Malaysia. Today, we have invited two PhD students doing mechanical material from University Putra, Malaysia. The first panel is Mr. Jaya Raj, anak lelaki Raja Segar, and the second panel would be Mr. Muhammad Muawidza bin Muda Bistari. Okay, so now allow me to begin this forum by telling you a little bit background on creep. The definition of creep is that it is a slow and progressive deformation of a material with time at constant stress, meaning a material that is required to hold a load over a period of time will experience creep until failure, which is then called creep deformation. There are three stages of creep, which is the primary stage, secondary stage, and the tertiary stage. These stages represents the characteristic of the material under the influence of creep at different times. Other than that, there are five factors that affect the rate of creep, which is the first, the load, the second one is the temperature, the third is composition, the fourth is grain size, and the fifth is heat treatment. So with that knowledge, for the first part, I would like to invite our panel, Mr. Muawidza, to tell us some applications of creep in real life.
Hey, thank you, moderator. Okay, today we are going to talk more specific on creep behavior of this material. So for our PhD, we did a study on creep behavior on supporting bracket, which is L-shaped bracket. We have choose this L-shaped bracket as the material that we are going to discuss. Generally, L brackets are used to hold or hang a shelf on the wall, and L-shaped brackets are subset of angle bracket. As we can see, there are two parts usually joined at 90-degree angle where one L arm is longer than the other one. Basically, the long part goes against the wall or underneath the shelf. So this bracket is made of metal which can begin to creep under a certain temperature. So this is the L-shaped bracket views from four different angles that we choose as the material for our study. So we can know the element for the thickness, the width, the length, and the height for the bracket component. So this is the example to calculate the stress value for the material. First, we need to know the dimension for each element. For example, in the table 1, where the length is 30 cm, the width is 3.5 cm, the height is 20 cm, and the thickness is 0.75 cm. So what happened if a load of 1000 Newton is placed on the bracket? How we want to know the stress value is by using this formula, which is stress is equal to the applied load divided by the surface area of the dimension. So as you can see, the stress is equal to the 1000 Newton divided by 1.05 meter square of the surface area. And we can easily get this value of the stress, which is the 952.38 kilopascal.
Okay, thank you, Mr. Muawidza, for that explanation. Now that we know the examples of creep, which is the L-shaped bracket, I would like to invite our other panel, Mr. Jaya Raj, to give some description on how creep will act on the bracket.
Thank you, moderator. So now I'm going to explain on how creep behavior for metals based on this graph. So when a tensile load is placed below the yield point on the bracket as shown in the figure 3, there will be an instantaneous strain which causes instantaneous deformation. So this is the first stage that happens. At the primary stage, the rate of metal deforms starts at a rapid rate and it decreases with time as the metal undergoes strain hardening before it reaches a constant value. So what will happen if the metal undergoes strain hardening? It offers more and more resistance for the further elongation. So at the secondary stage, the metal undergoes constant rate relatively due to strain hardening and recovery effects balance each other. It is due to creep in this stage takes place by viscous flow in the materials. At the tertiary stage, the rate of deformation of creep increases rapidly, and it happens when there is an effective reduction in cross-sectional area due to necking. It causes the strain rate increases rapidly and terminates when the material breaks or ruptures. So next, I'm going to show how Larsen-Miller parameter is used in this calculation. So first of all, I'm going to show the formula for the Larsen-Miller parameter. So this is the formula for the Larsen-Miller parameter. So LMP, Larsen-Miller parameter is equals to the temperature. This temperature will be in Kelvin times with C. This is a constant we call material specific constant, which will be 20 for normal metals. And then log TR. So this is TR represent time before the material undergoes failure. So okay guys, so from this question we can know that the temperature will be 27 degrees Celsius, usually a room temperature. So we'll get 300 Kelvin. So the time before the material undergoes failure will be 5 years, which will times with 365 days per year times with 24 hours per day. We get a total 43,800 hours. So we can find the value of Larsen-Miller parameter will be 7,392.44. So what will happen if the temperature increase? As we know, when the temperature increase, the rate of creep also increases. So the new temperature will be 35 degrees Celsius. So the total will be 308 Kelvin. So the Larsen-Miller parameter will be 7,392.44. So now we are going to find the new time before the material undergoes failure. So just sub the point. So we get the final value of time before the material undergoes failure will be 1 year 53 days. So this proved that when the temperature increases, the rate of creep also will increases, which causes the time before the material undergoes failure will decreases.
Okay, thank you, Mr. Jayaraj, for those detailed explanation. Okay, now we know that creep will happen on a bracket. Is there a way to prevent it? To answer this question, I would like to invite once again Mr. Muawidza to give us some idea on how to prevent creep deformation on the bracket.
Once again, thank you, moderator. So, as you can see on the left side is the normal figure for the L bracket, and the right side is the modified L-shaped bracket that we designed to prevent the creep. So we know that the L-shaped bracket are used for shelf to hold load for a period of time, so it will get through the process of creep. Therefore, one of the way to prevent the creep is by we adding the support structure that stick on the top and the bottom part of the L-shaped bracket, as shown in the figure 4, that make it look like a triangle structure. So this triangle shaped bracket has a simple look, but it is more stable and more sturdy compound shaped bracket, and it can withstand more load.
I see, that is interesting. How about Mr. Jayaraj? Do you have anything to add on how to prevent creep deformation from the bracket?
Thank you, moderator. So I also agree with the Abis that transformation in shape of bracket to triangle shape will help to prevent creep because it helps to support extra load as well. So in my opinion, there are other choices or other suggestion that could help to prevent creep. So proper choice of material also play a role in creep prevention. The material must be from high quality metal to ensure steadiness and durability. So the rate of, as we know, the rate of creep is highly depends on both stress and temperature. So the material structure that used for these modified brackets to prevent creep is stainless steel. So this is stainless steel triangle shaped brackets. So why we choose stainless steel? Because stainless steel has a higher and greater grain size and resistant to corrosion. Moreover, stainless steel has a higher resistance towards higher temperature, which helps to avoid the creep rupture on the supporting bracket.
I agree with. So I also would like to add another suggestion about the material of the stainless steel. So the modified bracket should not be painted or made by black color stainless steel. This is because the dark painted material absorb more heat compared to the light color. So this also will help to decrease the rate of the creep to the bracket. I think that's all about how we want to prevent the creep from the bracket.
Okay, thank you, panels, for the excellent answer. So we have just a few minutes more. Allow me to conclude what we have obtained today. First, we have learned that the L-shaped bracket is very susceptible to creep deformation, and both panels suggested that to minimize creep from happening on the bracket, we could add an extra support to the bracket and use the right material, such as stainless steel. It is also advised to not paint the bracket so that the creep deformation can further be avoided. Hence, with that conclusion, we have come to the end of the forum. Thank you to both panel for coming today, and thank you to the viewers for watching. Till we meet again next time, goodbye.